What we're going to do is take a look at IPsec. IPsec allows you to encrypt traffic going to and from one computer to another. It also allows you to ensure integrity of information, making sure it hasn't been tampered with. To set up IPsec, you need to go to your admin tools and to your local security policy. If you have a domain controller, you would need to go to the domain controller security policy. But you would want to be careful because that would affect all domain controllers, not just the one domain controller you would be sitting at. In addition, you can deploy out IPsec policies through group policy, affecting many computers at one time. Now with IPsec, we have three built-in or default policies, and here are the names. We have client respond only. A client policy, if it were assigned, if you were to right-click and assign this policy, would respond to requests to use IPsec but never initiate. The first one, server request security, would always request the use of IPsec, but would default to regular communication when speaking to a client that did not understand IPsec. And then finally, the bottom one here, secure server require security, would require the use of IPsec. Let's take a look at the secure server policy in more detail. So we've got three policies, and policies have rules. Now on the Rules tab, we have two rules, one for IP traffic, one for ICMP traffic. Now our rule for IP traffic is that we require security. So all traffic, all IP traffic will be using IPsec if we assign this policy. So policies have rules, and looking at the rule in more detail here, rules have filters. Policies have rules, rules have filters. I remember PRF as my acronym to remember that. Now for our filter list, the question here is what kind of traffic are we going to use IPsec with? It says all IP traffic. If we click on edit here, we'll notice that for our IP filter, yes, any protocol, any port, any destination, any source, any destination, anything would be set up to use IPsec. So what you can do with IPsec policies, you can set up a filter that filters out that only certain types of traffic will use IPsec, and we'll set that up in a little bit here. To continue looking at the properties here of a rule, if the traffic meets the filter, and in this case, are we looking at all IP traffic? Yes. What happens? The filter action is set to require security. That's going to enforce the use of IPsec. We'll take a look at that in more detail in just a second as well. Authentication methods. When two computers are trying to use IPsec, how are they going to authenticate each other? A feature of IPsec is mutual authentication. They both are going to verify that they're talking to the right computer. So just to edit this default one here, we'll see the three default authentication methods you can use. Now, if you have two computers that are a member of the same forest, you can use Kerberos. That is, the computers will check credentials in Active Directory. If the two computers are in different forests, you cannot use this. Your second option is to use a certificate. So you can install a certificate from a CA for the use of IPsec, also known as a computer certificate. And if both computers trust the issuing CA, then they will trust each other and IPsec communication will take place. And finally, our third option is called a pre-shared key. This is nothing more than a clear text password. So you would type in the exact same password on each computer for the pre-shared key. This is the least secure method, and you should avoid this if at all possible. So if at all possible, you'd like to use the default of Kerberos if they're in the same forest, or if not, you'd like to use certificates. If neither of these are available, then you have to use the pre-shared key. But again, you want to avoid that. So that's your authentication methods tab, your three choices. Tunnel setting specifies, are we using IPsec from point A to point B 100%, from computer A to computer B? Well, if we have, let's say, a tunnel endpoint, that is, let's say computer A is connected to a router, router 1 will say is connected to router 2 is connected to computer B, then you can specify the endpoints being just the routers. Typically, though, you just say end-to-end IPsec usage. And finally, connection type. Normally, you specify IPsec for all network connections, but you can be more detailed, say just for LAN connections or just for remote access connections. At this point, let's create our own policy just to see all the features again and get into a little more detail. So we'll just create our own policy from scratch. You just right-click, create IP security policy. We get a wizard. What's the name of our policy? I want to make a policy called AH only, and that'll make sense here in just a second. And for our policy here, we can choose which method of authentication to use. I'm going to use a pre-shared key, and I'm going to call it AH. I called the policy AH only. Again, that'll be explained here in just a second. So AH for our pre-shared key or password. And we're going to edit the properties here. So for our AH policy, we have really no rule. It's called the default response rule. We're going to go ahead and add a rule for all IP traffic. We get another wizard here. And you'll notice in this wizard we'll end up with the 5 tabs worth of choices. So we'll do end-to-end IPsec for all network connections, for all IP traffic. And for this policy, we're going to request AH security. So we're going to request security, we're going to request AH. So we'll set this up in just a second. And we're going to set up a pre-shared key of AH. So let me just click through these, okay? Here is our AH only policy. Looking at the properties of that policy, we have a rule for IP traffic. Let's check out this rule for IP traffic, and here we have our good old 5 tabs. Now, on the IP filter list for all IP traffic, again, we could filter out for different types of traffic. The default is just anything. However, just for example's sake, let's go ahead and add a filter in. Let's call this a test filter. And this mirrored checkbox basically says if you want the filter going one way, do you want it coming back the other way? And normally you say yes. So with a filter, you can specify source and destination IP addresses. So for source address, we can choose any source imaginable. We'll just say from my IP address. For destination, we can say to any IP address. What I'm saying here is that for any communication going from me to anyone else, I would like to use IPsec. For my source to any destination, I would like to use IPsec. And here you can filter out for protocols. For example, TCP. And we could say from port 21, for example. So you could be using IPsec with FTP traffic, for example. So if I were to remove the default filter and then leave in the test filter I just created, then what would happen is IPsec would only be used for FTP traffic, port 21 traffic, going from my source IP address to any destination IP address. And because we chose to mirror vice versa, any traffic coming from any destination to me being the source would also be using IPsec with just FTP traffic. I'm going to go ahead and cancel this because I'd like the filter to be back the way it was. So our filter should be back to just anything. Anything would use IPsec. Finally, the filter action tab, we are requesting the use of security, and this is the one we need to edit here for our AH only policy here. So for requesting security, we'll edit that. And then we'll have a large list here of security method preferences. Security method preferences. Let's take a look at the first one here and just click on edit. So this is, to back up just a second, this is the first preference we have for security. So if this computer does not match up with the second computer, they will attempt to see if they match up on further preferences. So they're checked until there's a match made between the two computers. So let's check out the properties of this. And our options are a little generic here. Integrity and encryption, integrity only, or custom. Integrity only would ensure that the data has not been modified in transit, so it prevents man-in-the-middle attacks. It makes sure that you are who you say you are. Integrity and encryption would also encrypt the data. So with just integrity, you're ensured the packets haven't been tampered with, but someone with a sniffer, a network monitor, could easily read the data. Or custom. Let's look at custom. And here we'll see the acronyms. There's AH. So if we provide integrity without encryption, without data encryption, that is just AH. If we provide both, we call that ESP. My analogy is to read the data, you would have to have ESP because it's encrypted. You can't read it. And with either case, you can even specify the level of algorithm you would like to use for your integrity or for your encryption. So triple DES there is 128-bit encryption, very powerful. Now for this custom policy, what I'm going to set up is an AH-only policy. So integrity, the AH protocol only. And there we go. So here is our custom policy. You'll notice there is AH integrity for SHA-1 there, and scrolling to the right, notice there's no ESP, so we do not have encryption of our data. Also, finally, notice the checkboxes down below. First checkbox here says to accept unsecured communication, but always respond using IPsec. The second checkbox says to allow unsecured communication with non-IPsec computers. So this is the request security option then. So we are allowing unsecured communication if another computer does not understand IPsec. If I were to uncheck this checkbox, we would now be requiring IPsec. Sure, we would accept unsecured communication, but immediately respond back saying I've got to use IPsec. And therefore, the other computer that originally initiated the communication would have to be able to use IPsec.